All right, here's our video on calculus, the first video, taking it to the limit, a little eagle reference. So to understand, we should basically first understand what is calculus, because it's probably single-handedly the greatest invention. Well, if you think of it as an invention, is it an invention or a discovery? That's another topic, but it's basically thinking about movement in math, the rates of change. And without calculus, right, there's no space travel. You're not having a phone or computer, or audio, any electronics, right, is limited without calculus. So it's a big thing we really need. And so we can thank Newton or Leibniz for that discovery. But that's the history. Let's just talk about limits. It's really the first topic we should talk about. And you should know about a function. So let's write that word function down. What's a function? And of course, you learned functions before. So let's just make sure that we just refresh ourselves what a function is. So a function is a relation. It's a relation between the input and the output, between the input, the x, right, the domain, and the output, y, right? So the domain and range. So for example, let's say we had y equals 3x, right? And we made our domain and range box up here. So if x is 2, let's say, well, we know we just substitute the 2 for the x, and y will be 6. So forth like that. And if we say x is 0, then y would be 0, right? We're just substituting. And so with function notation, right, we have the f of x. That's how we write it. And so if we say f of 0, we're just saying plug in 0 for x. That's what we're saying. Let's get a clean page. By the way, what you're seeing is the hyperbole in the background there, and I'll explain that also in the asymptotes. We'll talk about that. All right, the limit. So, when you think of limits, think of a speed limit, right? You can't go past the speed limit, although most people do sometimes, right? So, the limit. So, all it is it just describes how a function behaves. And we'll explain that even further. How a function behaves near a point. So, how a function behaves near a point. So, what does that mean? So, as you get closer to a point, here's the big thing. As you get closer, keep this in mind throughout the video. As you get closer to the point, right? But not, let's capitalize this, not at the point. So, let's put a box around this. Very important. Let's put a star. So, use a blue. As you're getting closer to a point, but not past the point. So for example, here you got a line. A line is getting closer and closer. Let's say you have a point here, and it's on the grid, and the point is whatever. It doesn't have to be anything. It could be 6, it could be 0, it could be any number. And your line is getting closer and closer and closer to it, but it will never get to it. It'll never cross it and never get to it. That's what we talk about in a limit. I'll explain that. So let's clear that out again. And let's just start right away. We'll have f of x, and we'll say f of x equals 5 over x. We'll start with this simple one. And we know that x cannot be 0. And this you should know already. Because anytime you have 0 in the denominator, it's undefined. So just remember that. And in case, I'm sure you do. In case you don't remember, just think about something. In case no one actually told you why it's undefined. Think if you had a fraction like, let's say 4/5. So you're just saying you have 4 out of 5, whatever they are, right? If you made a model of it. make a little box here. We made a model. And we had 1, 2, 3, 4. We had 5. 5 is the whole, and 4 are the parts. And you had 4/5, right? So this is how much you had. You had 4 out of 5. What do you think this would mean if you had 4 out of 0? Makes no sense. You're saying you have 4 out of nothing. Makes no sense. Do you see why it's undefined? Also, keep in mind, you can have 0 in the numerator, right? 0 could be in the numerator, but not the denominator. All right, I'm going to clear this out. Go back if you need to. So we know we can't have a 0 in the denominator. Let's rewrite it. Forget that little guy over there. Just leave him here. F of x, like the function, 5 over x. And we'll make a domain and range box. Almost said the range. F of x. So let's, if x is 0, we know that it's undefined. So we'll just say undefined. Right? And what if x is 1? We know we're getting 5, and if x was 2, you're getting 2.5, and so on. And if x was 3, 1.6 something, 1.67, and so on. So we have our box here. And of course, if we say x is 5, then we have 1. But let's go back to the 0. So we know that we can't have 0. And so when we graph this, there's going to be a gap. There's going to be a gap when we graph this, because we can't use 0. We can use any other number but 0. In fact, we can use something close to 0. So we're trying to get, that's what the limit is, right? We're trying to get close to 0 but not 0. So I'll just write this down. We are trying, we're all in it together. And this is just for this problem. Sometimes it'll be a different number, but for this specific function, we're trying to get closer, little box around it, closer to 0 without going to 0. So, but not, let's put our comment in there before our ELA teacher attacks us, but not 0. Anything close to 0, but not 0. And that's the limit. The limit is not getting to 0, but getting closer to it. All right, let's keep going. Now let's change the color for a minute. So let's say we said, instead of saying 0, we got something close to 0, like 0.9 is closer to 0 than 1. Well, that'll give you 5.5 with a line on top. But let's get closer. We can get closer to 0 from 0.9. What if we had 5 divided by 0.1? Well, that gives us 50, right? Just use your calculator, right? Get even closer, 5.01. That's 500. You see what's happening as we get closer to 0, the numbers are going up, right? So what if it was 5 divided by this? Let's just put a couple of zeros. What if, throw in another one. What would that be, right? Just, again, you see the numbers are rising very quickly. So let's look at the graph of that. All right. And you're seeing 2 lines here, and of course the gap. I'll put a little, oh, we got some purple today. Let's go back. Guess we should use purple, it's telling us. So this is a different graph. Let's go back to, in this graph though, you can see that the line is 1. It's not 0. Let's go back to the 0. All right, finally. So what this is, and let's make sure we have my pen ready. We'll keep purple because it seems like it wants purple today. This, where you see 2 lines that look like this, is a hyperbole. Don't say hyperbola unless you want to. And you can notice if we look at this over here, we look at this line, as the x gets closer to 0, right? We're getting closer to 0. The numbers are increasing like we showed before. See how they're increasing? This line that you see here will never cross the y-axis. It'll never cross it because the y-axis represents 0 right over here. It's never going to cross it. And on the other side over here, this line, because you can also use negatives for x, they'll never cross the 0 either. And you create this hyperbole. And the lines that it won't cross, as you can see here, I'll make it in purple. In this case, it just happens to be the x and y axis. They're not always that case. But these lines that the line is getting closer and closer to is called the asymptote. I'll write that down. So just remember, the asymptote, it will change depending on what is the line. And what is the line it's not trying to cross. It doesn't have to always be 0. If it's 0, then it'll be the x and y axis. The asymptote. That's the line. The hyperbole is the graph we're making. And you can notice one line is going one way, trying to get to the y, the positive y. The other one's trying to get to the negative y. And then you have it on the x. And of course, it'll never cross. So as, again, you see this line here, as x is approaching 0 from this way, the line's increasing. As x is approaching 0 from this way, because it approached from two sides, you can see the graph there on this side right here. It's getting lower on the y. Same ratio. So the way limits are written, you'll have limit, and they'll say as x is approaching something. In this case, we want it to approach 0 from both sides. And then they'll write what it is, f over x. And what will it equal? Well, as x is approaching 0, this will get greater and greater and greater. So it's approaching infinity. We'll do another one so it makes more sense. Okay, keeping purple. Use white. So if you saw, let's say, it said the limit as x approaches 1. So now it's approaching 1, not 0. And we had x squared minus 1 over, let's say, x minus 1. So why, here's a question for you, why can't x be 1? Last one, it couldn't be 0, because what happens, right? So you have 1 squared minus 1, so that's 0, and 1 minus 1 is 0. Again, you can't have 0 in the denominator. Undefined. And like I said before, you could have 0 in the numerator. So we want this limit to approach 1 from both sides, but it can't be 1. Close to 1. Think of that. All right, put a line here. So let's say we can't have it as 1, but we're trying to get close to 1. So what if we made it 0.9? 0.9 squared minus 1 over 0.9 minus 1. Go ahead and plug that into the calculator and you get 1.9. So let's get closer. What if we did 0.99 squared minus 1 over 0.99 minus 1? Getting closer. 0.99 is closer to 1 than 0.9. What do we get? Well, we're getting closer, right? We're getting 1.99. Let's do one more. What if we did 0.999 squared minus 1 over 0.999 minus 1? What'd you get? Plug it in the calculator. 1.999. So what do you think it's getting? As we get closer to 1, as the limit gets closer to 1, seems like the answer is 2. We're getting closer to 2. So that's the answer for that. Let's look at a graph of that. All right, and so you see that red circle. Let's make sure my pen's ready. So again, x is, as we approach 1 from both sides, we're approaching 1 this way, and we're approaching 1 that way. As we approach 1, the closer and closer we get to 1, we're getting a figure closer and closer to 2. Right? 2. And so again, like we've been using it going like 1.991 and going this way. But what if we got it the other way? Like instead of saying, let's say we had 1.01, what would you get? So on this side, we used, remember, 0.9 and 0.999. We were getting closer and closer. 0.9999. Keep going with your nines. You're getting closer and closer to 1, but you're not 1. And on the other side, 0.1.01. And, just plug that in. 1.01 squared minus 1 over 1.01 minus 1. And you're getting 2.01. So you're getting closer to 2 on the other way. And if you kept going, let's say 0.001 squared minus 1 over 1.001 minus 1. Just plug it in the calculator. 2.001. See, you're getting closer. As you get closer and closer to the limit of 1, you're approaching 2. But you're never going to get to 2. That's the limit. You're never getting to 2. So let's try one more. Let's clear that out. All right. So let's say we had a problem. Find the limit as x is approaching, let's say, 1. So we know that. Can't get to 1, but it's approaching 1. And this is what you have. Let's say you had 2 minus 2x squared over 1 minus 1. So what do you think the answer would be based on what we did so far in this video? So remember, make that x, not a 1. Fix that x. So we know x can't be what? Can't be 1. It says it right there. The limit is 1. It can't be 1 because you get undefined. 1 minus 1 is 0. If you plugged in the 1s, right, you would have 2 minus 2, and you would have, because you plug in x for 1 over there, and then you have 1 minus 1, and you'll have something that's undefined. Remember we said that? Undefined. So we know we can't use 1. But if we can get close to 1, remember, you can get close to 1 by saying, 0.9 is close to 1. And on the other hand, 1.01 is close to 1. But you can get closer, right? 0.99999, keep going forever, is close to 1, but it's not 1. And 1.00000, you can just keep going. That's close to 1 also. So remember, on both sides. And you'll see a number that it's getting closer and closer to 2 as the limit approaches 1. So what do you think it would be? Why don't you try that? All right, let's use yellow to get the answer. So if we took this equation, we said 2 minus 2 times, let's say 0.9 we used, and we had to square that, all over 0.9 minus 1. And if you did that, you would get negative 3.8. So let's do another one. Let's get closer to 1 and see where we're getting closer to. So do another one. What if we did 2 minus 2 and 0.99 squared over 0.99 minus 1? Plug that into the calculator. You're getting negative 3.98. So by now you're seeing a pattern. What do you think the answer is? The answer will be negative 4. As x approaches 1 from both sides, the answer will be negative 4. All right, that's our first video today on calculus.